Hello and welcome back to In Search of a Way, an introductory survey of theological topics. Next week is when the real fun begins. Next week begins the engaged portion of the class. Starting next week for the rest of the semester, we're talking about contemplation and meditation. I'll have some cool stuff for you to do after this week. This week we're talking about theology and science. Kind of a hot button topic. It's a topic that comes up a lot in the news and various other venues these days. I'm lecturing without a bottle of water. Impossible! I'm going to pause the video and get my bottle of water. You can pause too and get a bottle of water if you need one. Good stuff. I actually started off as a physics major. I had wanted to get into quantum physics. I wanted to be sort of like an Albert Einstein. I wanted to study the mysteries of the universe. And the first class, let me rephrase that. The first theology class that LMU hired me to teach was a class on theology and science. So this week I'll just be kind of picking a few of the more interesting topics from a course like that to give to you. What I want to talk about today is three things today. First, I want to do a little bit of reflection on why theology and science go together. Why do they so often pop up in the same conversation? You don't see a whole lot of programs about theology and the culinary arts. You don't see a whole lot about theology and economics, although Pope Francis might be trying to change some of that. You don't hear a whole lot about theology and football. So why theology and science? Why do those two topics seem to be a natural fit for discussion? That's the first thing I want to reflect on. Then I want to talk a little bit about a famous historical incident that involves theology and science. Give you a little bit of information you might not have known about the Galileo affair. And lastly, the last thing I want to do today is discuss some various models that have been proposed for how theology and science might relate to each other. If you're interested in these topics, a couple of classic books to read. John Polkinghorne is one. John Polkinghorne was a quantum physicist. He spent 20 years working as a quantum physicist before becoming an Anglican priest. And he wrote the book Theology and Science. It's a must-read if this is something you're interested in. The other book is by Ian Barber. It's called When Science Meets Religion, another classic text. It's more philosophical in nature, but it also has a lot to be said about this. So at the end of this lecture, I'll talk about how theology and science might relate to each other. In the next lecture this week, I'll be talking about a special topic, theology and quantum physics. If you hate science, well, brace yourselves because it's going to be a wild lecture. It'll be a little bit technical. If you like science, I hope it's fun for you. And then the last lecture this week will be about something you've probably encountered at some point in your life, the evolution debate, theology and evolution. A couple of caveats about this week's lectures. Once again, my discussion is framed in terms of the three Western monotheistic religions. I speak as somebody who's thinking about theology from a Jewish, Christian, Muslim point of view. I've included a reading for you this week about how science relates to some Eastern religion. But furthermore, my theological training, although I have some knowledge of world religions, especially Buddhism, I'm primarily a Christian theologian. I primarily work in the Roman Catholic tradition. So if I don't have a lot to say about, say, Taoism and theology, there's stuff you can read about that. I have talked about that in other classes. But I don't know Taoist theology that well. So talking about Taoism and science, Taoism and quantum physics, we can look at some articles about that if you wanted to, but that's not what I'm going to be doing this week. So, how you doing? Theology and science. Why do they so often come together. You might have your own answers. I'd love to hear some alternative thoughts on this if you want to put some thoughts down in the com box. My immediate gut reaction has to do with the idea that religion, as well as contemporary science, well, they have some features in common. They both claim to be providing answers. They both claim to be providing comprehensive, kind of complete answers. They both claim a very high level of authority and certainty. They both claim to be doing something really important. They both claim that what they're discovering has consequences for every man, woman, and child who lives, right? Scientists claim to be able to invent cures for diseases, to grow food, to produce a better life for everyone. Science claims to be able to tell us the secrets of how we think, what life, where life comes from, all those questions science claims to have answers to, and have certainty about its answers. Religious organizations, religious bodies often claim the same things. Answers to questions. What is life all about? How ought you to behave? What happens when you die? And religion claims to have certainty about these questions. Scientists and theologians seem to have certain traits in common. This is just occurring to me. I hadn't prepared these remarks. Scientists and theologians both tend to be very curious people. They're people who deal with questions. They deal with their questions methodically, systematically. They claim, I think theologians and scientists would give similar answers to why they investigate the questions. They do so to learn answers, but also to share truths. It's unusual for a scientist or a theologian or a philosopher to want to just go work on these questions and not share their discoveries. So scientists and theologians have very similar personalities very often. There's a lack of satisfaction with appearances. The world of appearances, right? The phenomenal world that you see and perceive with your senses. Theologians, scientists, philosophers, they want to get behind the appearances. There must be more to things, more to the world than just what affects our five senses. Whether you're a scientist or a theologian, you're interested in that. So science and theology, they have some natural overlap in this sense. If you're an economist, I'm not trying to put down economics. If you're an economist, though, the questions you answer, they have a kind of limited scope, right? They're good insofar as trying to run a business or trying to increase the GDP of a nation. Economists don't usually claim that the questions that they're answering have consequences for every man, woman, and child who ever lived, right? At best, they have consequences economics has consequences at best for every man, woman, and child at dinner time, right? Economics can tell us something about the food supply. So can culinary arts, for that matter. Chess players, if you study chess, I mean, you can really study chess. I mean, if you want to be a professional chess player, you have to spend the first 3 years just memorizing openings. You have to memorize thousands of famous chess games, thousands of lines of openings. Okay, well, what's the best way to play the Sicilian defense? There's a great question if you're a chess player. The answer does not have consequences for every man, woman, and child who ever lived. Science, theology, philosophy, those disciplines claim to have answers for everyone, important answers, things that, well, at least theologians and scientists both seem to believe that their discoveries are the kinds of things you should get out there. The Earth is round, and the Earth goes around the sun. We know this. And it really doesn't have that much consequence for me. If I didn't believe that the Earth was round, my life would be exactly the same. And yet, scientists seem to think it's important that I know that the Earth is round. I mean, I had to learn it in school. So scientists, like religious people, want to force beliefs on other people. And you'd think I'm saying that like it's a bad thing. No, I'm just describing a fact. Okay, science, theology, religion, right? There's the on the other hand, right? A chess player does not think that it's crucial that we teach third graders how to play the Sicilian defense. Okay, so science and theology have overlapping concerns. Scientists and theologians tend to have similar personalities. So, I don't know, maybe you want me to say more about why these two topics go together, but hopefully it's fairly intuitive for most of you. In the West, in our Western tradition, religion and science have a long relationship. Contemporary science in the 15th, 16th century comes out of a very religious project, okay? The rediscovery of Aristotelian sciences by Muslims and the Arabic world, and the Persian world, and the Muslim community in Spain had rediscovered Aristotle. And a lot of early scientific work, in the Middle Ages anyway, was done in the Islamic communities. They were really the most scientifically and technologically advanced culture in the Middle Ages. They had the best hospitals, the best scientists. Eventually, Islam as a religion, it went through a period of its history where it was not on good terms with science. An Islamic thinker by the name of Al-Ghazali actually repudiated all of science. What Al-Ghazali taught was that there's no such thing as natural causation. Let me give you Al-Ghazali's own example. You see a bit of flame. It comes in touch with a piece of paper. The paper goes up in flames. Scientists tell us that that's because flames make other things to be on fire. Al-Ghazali said nonsense. God makes things happen. God alone makes things happen, said Al-Ghazali. Fire has no power. Nothing has power other than God. God, in God's wisdom and compassion, said Al-Ghazali, does things with a certain regularity. Because God doesn't want us to live in terror and confusion, every time a flame touches paper, God has compassionately caused the paper to be on fire. This is called occasionalism. That there is no such thing as causation. Everything is an occasion for God to act directly. So eventually the Islamic thinkers came to be less concerned with science. Nevertheless, the conviction common to Jews, Christians, and Muslims in the West that the universe is orderly, that God creates an orderly universe, compelled Christian monks to try to understand the orderly universe. They thought that it was a holy task. It was a Christian task to engage in science, to figure out what are the physical laws that govern things. This really is what led to that scientific revolution of the 15th, 16th centuries. It's what led to the invention of things like telescopes and to observations about the night skies and star charts. I mean, a lot of that had been going on for centuries, going all the way back to Aristotle, 300 years before Christ. But the idea of reinvigorating the project was a very Christian project. Now, there was a problem. People back then, of course, believed that the Earth was the center of the universe. Not an insane theory. I mean, you look around, and the universe looks the same every direction you look. It makes sense that we would be in the center. And everything goes around the Earth. All the stars, planets, and so forth. Now, the problem came when people were looking at these things with telescopes. Because things tend to go in a regular order around the Earth, year in, year out, very predictable patterns. Except certain objects, such as the planets that they were able to observe with telescopes, every so often do something very weird. Every so often a planet for a few days out of the year, goes in the wrong direction before going in the right direction again. Okay, what do you do about that? Well, not a problem, thought the ancient astronomers. What they did was they created a model of the solar system, of the whole galaxy, actually, really, of the whole visible night sky. Earth in the middle, and all the other objects in the sky, the stars, the sun, and so forth, travel around the Earth in little mini circles. They called those epicycles, those little mini circles. Well, with the invention of telescopes, what we discovered was that some of the objects in the night sky, some of the planets, like our own, have moons. And those moons themselves seem to be on epicycles. They go one direction around the planet, but every so often go backwards. What's up with that? What is up with that? Well, for one thing, it really raised a serious question about claiming the Earth was in the center of everything, since other planets had moons going around them. Well, one theory was this. Yeah, I mean, eventually the model of the galaxy that astronomers made was extremely complicated. Eventually you had objects with epicycles, and eventually objects had epicycles within epicycles. Ancient astronomy eventually, just thousands and thousands of epicycles that ancient astronomers had to learn. It was... Now, then some astronomers realized you could simplify the model tremendously. You could simplify the model tremendously by putting not the Earth in the center, but the sun. Put the sun in the center, put the Earth on a rotation around that, along with the other 5 planets that they knew about. And you could get rid of all the epicycles and still make accurate predictions. Well, okay, not bad if you're just trying to make predictions. The problem was a guy called Galileo. Now, Galileo was a devout Catholic. Galileo also put forth the idea that this model of the universe, with the sun in the center, Galileo suggested that was not just a good prediction-making model, but that was the reality. That's actually how the galaxy looks when you look at it. Now, at that time, the Pope contended, and the Pope himself had some astronomical training, the Pope contended that for theological reasons, which are really rather arcane to think about now, the Pope insisted that the Earth was the center of the galaxy. And so there was a dispute that erupted between them, with Galileo saying the sun's the center, and the Pope saying, with the Pope saying the Earth is the center. Galileo wrote a little booklet about this debate, and he wrote the booklet in the form of a dialogue. Now, he must not have thought this out too far, because the character who defended geocentrism is the view that the Earth is in the center, he gave that character a name. In Latin, it was something like stupidissimo. He called it stupid. And the Pope took that very personally. The Pope thought he was being called stupid. Eventually, Galileo was called to a church trial. And he was tried by a guy named Robert Bellarmine, after whom the Bellarmine School of Arts and Sciences is named. Galileo was eventually found guilty of preaching an anti-religious falsehood, and he was placed under house arrest. He was not tortured. You'll sometimes hear people say Galileo was tortured. He was never tortured. Now, you probably already know much of what I've just told you about the Galileo affair, but I want to clear up a couple of misunderstandings. According to every account of the trial and the exchange between Bellarmine and Galileo, things were not quite what you normally, the picture you normally get from popular depictions. For one thing, Galileo was making a number of very sophisticated theological arguments. Galileo had read his Augustine and he knew the different theories of biblical interpretation. Galileo knew full well that there was no theological doctrine for the Catholic Church requiring that the Bible be read in such a way as to uphold geocentrism. And Galileo made that point at the trial. So, sometimes the Galileo trial is depicted as science on one hand, religion on the other, and they had to duke it out. But that's really not what was happening. The two, science and religion, kind of blended into one topic, and both sides were gliding back and forth between the two quite easily. Galileo was talking about theology. Bellarmine was talking about science. Let me tell you what Bellarmine said at the trial. First of all, Bellarmine noted that Galileo himself was getting the theory of tides wrong. Galileo taught that his theory, where the Earth goes around the sun, could explain tides. You know, the tide goes up and down at the ocean. Well, why is that? Well, according to Galileo, it's because the Earth is moving. And just like if you take a cup, if I had this cup full of water, it's not, it's empty. Well, what if it was full of water and I moved it like that? Well, of course, the water's all going to spill out. Galileo said that's what's happening with the tides. Bellarmine realized that was totally unnecessary. Bellarmine realized that the tides correspond to the moon. Other scientists at that time had already proposed that the moon's gravity could be what affects the tides. Galileo was not having it. The scientist was insisting the science was wrong. Then Bellarmine dropped a real science bomb on Galileo. Bellarmine asked Galileo this: where is the stellar parallax? Stellar parallax, okay. You know how when you're driving in a car down the highway, and you pass all the light poles, all the electric poles on the highway, and if you're looking out the window, they go by you much quicker than the trees behind them, but the trees are going by quicker than the mountain behind them. The mountain still is going by you quicker. It looks like it's going by you quicker, I should say, than, say, the sun. Okay? The farther things are from you, the slower they seem to be passing by you. That's called parallax. Okay? When you're in a moving car, things closer look like they're moving faster. That's called parallax. Well, asked Bellarmine, if the sun isn't in the middle of all the stars, why is it that as the stars are moving around us, why is it that when you look at the sky, the stars, as they move, always seem to be equidistant from each other, other than those few times a year when they switch directions, right? The night sky, the constellations in the night sky remain fixed, right? Think about the Little Dipper. Or the Big Dipper. You go out at night, I can see the Big Dipper more easily. I go out at night, I look at the Big Dipper, it's always there. It might be in a different part of the sky at different times of night, right? But the stars are always in the same configuration. Now, according to Galileo, those stars are not all equidistant from us, right? According to Galileo, those stars, like the Earth, are going around some other central point. Their relative position to each other should be changing, just like the mountain and the trees behind the light pole change their position relative to the light poles. Bellarmine asked Galileo about this. All right? Bellarmine said the fact that the stars always stay in the same configurations year in, year out, shows that the Earth is in the center. And Galileo couldn't answer that one. Galileo had no answer to the objection about stellar parallax. So, what was the scientists' justification for heliocentrism? the view that the sun is in the middle of the solar system. Observation? No! Spaceships hadn't been invented yet. You couldn't observe that. Galileo stuck to his guns for one reason: simplicity. Now, this is called sometimes in philosophy of science Occam's razor, named after a medieval philosopher named Occam. Occam's razor. Always prefer the simplest theory. That's all it is. Always prefer the simplest theory. So sometimes we talk about science like science is just a matter of verification, right? You propose a hypothesis, you do an experiment, you verify it. That is such an oversimplification. A lot of science proceeds by employing Occam's razor. The heliocentric model of the universe, which got rid of all those epicycles, those thousands of epicycles, was just a simpler theory. And that's why scientists preferred it. That's why Galileo preferred it. And scientists still do this, okay? Scientists, here's another assumption scientists make just for the sake of simplicity. There's an assumption that the universe looks the same in any direction you look. There's an assumption that any direction you look at the universe, it looks the same. And we have some observational evidence to prove that, okay? What's called background radiation, no matter which direction our telescopes are pointed, background radiation, which is radiation left over from the Big Bang, has roughly equal amounts in every direction. So the universe does look the same in every direction. Then there's a second assumption, untestable, mind you, that no matter where you are in the universe, it still looks like that. That even if you are millions of miles away, no matter what direction you pointed your telescope, you'll get the same amount of background radiation. This is just an assumption. They can't test that. They don't have the tools to test it. It's just an assumption, right? There's no observational evidence, not even any mathematical evidence to prove it. It just makes all the theories simpler. Okay, so how might science and theology relate to each other? I mentioned Ian Barber. He wrote the book When Science Meets Religion. He proposed the kind of classic taxonomy, 4 ways science and religion can interact. I'll go through these fairly quickly. You can study them for yourself, think about them for yourself if you'd like. I might ask about them on the midterm exam. Conflict. Model 1 is conflict. Either science is right or religion is, and they can't both be right, and you can't be both. People who subscribe to a conflict model of science and religion simply believe that they cannot both coexist, right? And there's religious people who subscribe to this, and there's scientists who subscribe to this. You either trust the scriptures or you trust the scientists. Make your choice. Independence. Some thinkers contend that science and religion are both legitimate domains, but keep them away from each other because they're trying to do different things. Sometimes these are put in terms of dichotomies such as science answers how questions, religion answers why questions. Sometimes this is put in terms of a dichotomy such as science is concerned with the objective, religion is concerned with the subjective. Science tells us how the world is, religion tells us what our values should be. Things like that. Science can't tell us how to behave. Religion can't tell us how to cure the coronavirus. So some people prefer an independence model. Dialogue. Science and religion are both legitimate domains. Sometimes they're answering different questions, but sometimes the questions are concerned with overlap. Where do human beings come from? Where does the universe come from? What is life? What is death? How does life begin? How old is the universe? Sometimes people claim that scientists would do well to consult with theologians, and theologians would do well to consult with scientists. Convergence. Some people have made a very strong claim, this is kind of an interesting position, that science and religion are actually up to the same thing. They're using different languages to do it. They're using different languages, different vocabularies, different methodologies, but they're talking about the same reality, just from slightly different angles. And according to proponents of this position, they'll eventually merge into one. Science and religion will merge into one. A Jesuit by the name of Theology was a famous proponent of this. That the study of evolution, according to Theology, was the study of how life is ultimately evolving into something that's kind of pure spirit. It's evolving into union with God. So we'll talk about all four of these in our discussion this week. I'm interested to know what you think about them. So that's enough for us to start thinking about for now. Okay, I hope you're having a good week. We'll talk about this more. On to quantum physics.